First of all, I want to thank the organizers of the Media, Arts and Design AI conference for inviting me to present part of my work and for putting together such an interesting conversation about media, arts and technology. This talk will focus on a computational art project I am currently developing at METALab at Harvard for the exhibition series Curatorial Agents in collaboration with the Harvard Art Museums. The title of the project is This Recommendation System is Broken, which is echoed in the title of the presentation, The Brokenness in Our Recommendation Systems, Computational Art for an Ethical Use of AI. The idea of brokenness in algorithms comes from previous research I conducted in the field of media studies. While I was researching online platforms, I noticed ongoing online conversations pointing at the limitations and imperfections in algorithmic recommendation systems. For instance, over 2 years ago, some users started complaining online about errors found in recommendation systems on streaming platforms like YouTube by hinting at the fact that they might be broken. Is recommended videos currently broken? This is weird, YouTube must be broken. Is YouTube's recommendation system broken? Honestly, YouTube's recommendation system is broken. Around the same time, in 2018, Wired editor René DiResta wrote an article on the need for a better recommendation system, acknowledging that recommendation engines are, so to speak, broken. And I quote, "The recommendation engines we engage with are broken in ways that have grave consequences, amplified conspiracy theories, gamified news, nonsense infiltrating mainstream discourse, misinformed voters. Recommendation engines have become the great polarizers." End of quote. Over the course of my research, I kept on thinking about this idea of brokenness. What is a broken recommendation system? Is it a broken code? Is it a broken algorithm? When it comes to code and software design, a common suggestion is not to leave broken windows unrepaired, meaning bad designs, wrong decisions, or simply poor code. But how do we determine this brokenness from a humanistic standpoint? What does this brokenness represent from a perspective that brings together computer science and cultural studies? The answer can be found in a discipline that studies the social impacts, biases, and limitations of algorithms from a critical humanistic standpoint, critical algorithm studies. This discipline treats algorithms as relevant objects for academic fields going beyond computer science and other scientific domains to embrace media and cultural studies, but also social sciences. Common topics explored range from what is the relationship between algorithms and the society, between algorithms and cultures, to the analysis of algorithmic governance and policy, up until the design of algorithms and their human component. All these topics rotate around a central question: what are algorithms? In 2017, the scholar Nick Sievers suggested that we should look at algorithms as culture, not just within or in relationship with culture. Instead of offering a correct mathematical definition, he proposed to approach algorithms from a pragmatical standpoint, that is to say, considering their empirical and practical existence. Within this critical framework, I ask a more specific question. What is the interplay between algorithms, such as those underlying sorting and filtering recommendation systems, and cultural collections, meaning media collections, but also art and museums collections? This question, along with the project I present today, echoes the four themes discussed in this conference: media, art, design, and artificial intelligence. As we cover these four domains, first of all, we should ask, what are algorithmic recommendation systems? Online recommendation systems are information filtering systems that provide users with streams of prioritized content based on expected individual preferences. For example, content-based recommendation systems build upon personal taste and the content liked over time to make new suggestions. or as collaborative recommendation algorithms sort content based on users sharing similar tastes and preferences. Other algorithms combine both. While they can be of different types, content-based, collaborative, or hybrid filtering, recommendation systems typically share the use of machine learning technologies as forms of artificial intelligence able to perform predictions and profile personal taste. Of course, predictive context personalization and automated sorting bears biases and limitations, especially when applied to cultural objects. There is a need for defining an ethic of algorithms. More than algorithms as culture, we should start thinking about ethical algorithms, as suggested by Michael Cairns and Aaron Roth. As scholars, researchers, artists, designers, and media practitioners, we are called not only to discuss the ethical use of artificial intelligence, but also to actively engage in the creation of what I define context-sensitive algorithms, or as Cairns and Roth put it, socially aware algorithm design. So when I was asked to reflect on AI-driven practices for museum collections for the METALab's project Curatorial Agents, I started from three main points. First, the code I created had to be context-sensitive, meaning it should account for the institutional context of the collection itself. It has to be culture-specific as well, meaning it should be aware of the cultural context it operates in. And finally, it should be oriented towards scenario planning instead of focusing on prediction. By scenario planning, I mean practices of future making. A series of early studies on recommendation systems have shown that the creation of context-aware recommender systems, meaning inserting in the machine learning process contextual information and variables, such as time, location, social context, allows for a more effective machine learning. This research on this topic initiated, among others, with a project funded by the European Union and coordinated by the Spanish innovation company Telefónica Investigación y Desarrollo between 2011 and 2013. The research project states that recommender systems have become essential personalized navigational tools for users to wade through the plethora of online content as they allow users to discover relevant information that they would have never known it existed. In recent years, the importance of this information discovery process, as opposed to explicit keyword-based search, has been emphasized. Current research in recommender systems, while taking into account the relation between user and item, often ignores the context of the recommendation. We define as context any environmental, temporal, or otherwise variable that influences a decision users make. End of quote. I propose to bring this framework to the fore to include a complete revision of what recommendation systems are intended to provide in cultural context and when applied to cultural objects. Bearing in mind this aim, I started tinkering with programming on digital museum collections to investigate the concept of context awareness, as well as to propose an art project that dismantles the very principles of algorithmic recommendation systems and offers a new viable solution. The project I present today is part of Curatorial Agents, a METALab series of interactive projects exploring machine learning in, around, and about the Harvard Art Museum's collection, as stated on the website. I invite you to check METALab's website for more information about these and other projects. I created this recommendation system is broken as a computational art project that advocates for a socially aware, context-sensitive, culture-specific, future-making oriented algorithmic design for recommendation systems. It does so by inserting randomization in the selection of content based on the least viewed works of art in the Harvard Art Museum's collection. The Harvard Art Museums comprise three museums: the Fogg Museum, the Bush Reisinger Museum, and the Arthur M. Sackler Museum. The overall collection counts over 200,000 works of art. Only less than 1,500 are currently visible in the museums, which is to say less than 1% of the collection is being seen. A predictive recommendation algorithm would probably neglect a large part of the collection, and most works of art would remain unseen, invisible. This video shows some of the artifacts we are able to discover by running the code I created. Imagine you're looking at the Gare Saint-Lazare, Arrival of a Train, painted in 1877 and considered to be one of the most iconic Monet paintings. If you like it, most recommendation algorithms might suggest other Impressionist paintings, or maybe they will forward you to other versions of this painting at Musée d'Orsay in Paris or at the Art Institute of Chicago. Or again, they will tell you that you might like more works by the French artist Claude Monet. Maybe Redboats, Argenteuil. You are at the center of one of the most popular 19th century European art movements. But what if artificial intelligence could take you outside the room, far from the center? What if artificial intelligence could take you at the margins to discover undervalued, hidden artworks? The recommendation system I created is broken, which is to say, it doesn't ask you what you liked, it doesn't collect your data, it doesn't try to identify your interests or create predictions. Instead, it makes visible the invisible artifacts in the collection. It filters items that you have never seen with inaccurate or incomplete records, such as untitled objects with curious descriptions, like the midnight sun in Melville Bay in August. The picture of Melville Bay in Greenland is part of a series of photographs taken by William Bradford during an art expedition to the Arctic regions in the late 19th century, quite unique. Or this mural fragment with later overpainting by an unknown artist. This object dates back to the 12th and 13th centuries Iran, and it's part of the Seljuk Ataturk period in Persian art. An impressive work of art with lots of history that we probably would have never seen if we had used a typical recommendation system. Again, unidentified regions, like this view of cliffs along a shoreline. Or unidentified cultures. This is actually a pretty accurate categorization. This project ultimately uses machine learning to break normativity, decenter our perspective, and generate alternative instances of visibility, while reimagining peripheries and borders within the Harvard Art Museums. By leveraging on a conceptual use of programming, the project challenges the audience to explore the biases of machine learning in generating instances of visibility on media platforms, leaving aside a great number of artworks that end up becoming marginal, fitting into the large pool of marginalized art histories. In this case, what we might call brokenness is about using computational methods for randomization to explore an ethics of algorithms, one that observes how AI-driven information filtering systems and their design are transforming media, arts, and culture. Here I argue for a new perspective on the concept of brokenness in algorithmic design, one that leads to alternative options to the long-time dominant predictive model inherited from art sciences. Beyond more scientific definitions, in popular belief, a broken algorithm is essentially perceived as one that fails in performing accurate prediction. And yet, precisely embracing this form of brokenness can lead to new explorations and discoveries, overcoming the limitations of using biased training sets for machine learning. Drawing upon a critical and ethical approach to algorithms and new media practices, for this argument I start from the premises that art shouldn't be handled in the same way as finance or marketing. Algorithms for cultural institutions should not be guided by prediction, popularity, or money-making. Finance works at a scale, culture doesn't. Art and cultural institutions do not need that scale. Museums and art collections have very specific identities and histories that cannot be treated in the same capillary way. We need diversity in algorithms, meaning algorithms that are tailored for each cultural institution. The Albert Art Museums in Cambridge, Massachusetts might need a different algorithm than the Museum of Modern Art in New York or the National Museum of Anthropology in Mexico City. Exploratory programming and creative coding for arts and culture might offer a viable solution for making algorithm design more inclusive. With this project, I want to shed a light on the urgency to prevent a small set of algorithms to define all these media and cultural processes we live in every day. This is a topic that also opens up to a discussion on governance, privacy, and the ways personal data are handled. For instance, we can ask, when consuming cultural and media content, do we really need prediction and personalization? Or perhaps we need an algorithm that leads us outside of the beaten path and onto new directions and explorations of our own cultural biases. Some projects were already developed in this direction, such as the project Art I Don't Like by Sarah Frost and Manu Matthew Thomas, based at the Creative Coding Lab at the University of California, Santa Cruz. Art I Don't Like is an anti-recommender system where the algorithm filters work of art with a low similarity score, finally showing users a work that they might not like. If you don't know this project, I'd invite you to check the website and play with this anti-recommendation system. It's a great way to discover new artworks. I myself use the website of Art I Don't Like, and as it turns out, I'm going to aid Marc Chagall's painting The Circus. This is just one example of prototypes that integrate neural network technologies, creative coding, and other programming resources for managing art and media collections. Other interesting projects focusing on artificial intelligence and museums use algorithms as curators in order to create web-based, data-based selection of content that goes outside of the canonical, often biased, human perspective. The Museum of Digital Art in Zurich, Switzerland, for instance, uses an algorithm called HAL 101 to compare past patterns, internet searches, available data to select and organize artists and content for future exhibitions. Artists are then responsible in a second phase for creating their own exhibition. This is meant to avoid biases in selecting artists' nationality, age, gender, or financial factors. Another example is Recognition, winner of the IK Prize 2016 for Digital Innovation. Recognition is, and I quote, an artificial intelligence program that compares up-to-the-minute photojournalism with British art from the Tate collection, end of quote. Over 3 months, Recognition's algorithm created a virtual gallery by searching through Tate's collection of British art and archive material online and comparing it with news images. Projects like these help generating unforeseen connections across history, geography, and culture. Way before these more recent examples, a curious attempt to revolutionize recommendation systems appeared in 2006 under the name of Unsuggester. The Unsuggester was introduced as the worst recommendation system ever devised, since it recommended books using the format "if you have read this, you are unlikely to read this." In her book, The Participatory Museum, Nina Simon asks us to imagine a similar principle applied to museum visits. I quote, "People might be intrigued to learn that if you always visit the mummies, you may never have explored the fish tanks." Recommendation systems must meaningfully respond to users' profiles, but they don't have to be optimized solely to provide people with more of what they already have. End of quote. As we approach a seemingly perfect, non-human sense of artificial intelligence, the risk is to become unable to understand the complexity of it and its biases or inner brokenness. Purposely breaking recommendation systems means opening up a way for creating our own human-oriented algorithms. To conclude, the question I ask is, are artificial intelligence and machine learning technologies ready for this disruptive shift in algorithmic culture? Thank you.